So we start practice 5.2 and we will speak about nonlinear production function. So for production function, we have to know some start data. The data about labor, about capital, about Y, maybe output, and we have to know the type of relation between these variables. So first of all, I add the substat data, initial data for you in our screen. So now we have some columns with some data. So we have, for example, 25 factories. And in these factories, we have some labor resources. So it's how many people work in some factory. The volume of capital, how many capital investments we can find in some factory, and the volume of production, how many output we can create in the some maybe factory. We have information about 25 factories, so we have to create a relationship between our independent values, it's our labor resources and capital resources, and our and our dependent variable. So in the previous previous classes, we spoke only about linear model, and this linear model was very, I think, very simple for you. So um, for these calculations, we can write this formula here. So A0 plus A1 multiply L plus A2 multiply K. So it's a linear type of model, and let's check how we can create linear model for this data. So for this, we go to the data analysis, select here regression. After that, we add information for our current Y, it's a volume of production, and add information about our X's, it's data about our L and our K. And for output interval, let's select maybe here. Press OK, and we achieve information about our current regression, about current linear regression, and we can check some main characteristics of this model. So here you can see information about correlation coefficient, about determination coefficient, and about Fisher criteria. This coefficient, correlation coefficient more than 0.75, but our current determination coefficient less than 0.75. Our F criteria, I think it's a big value, and here you can see significance F. Here we see value less than 0.05, so we can create conclusions that our model has adequacy in data, for example. But let's create hypothesis, and in this hypothesis we can achieve knowledge about non-linear type of this model. Because in our science, in our econometric science, we discuss we don't discuss only linear model, but we can discuss non-linear model too. And for this non-linear model, we have to speak about nonlinear type for this data. Let's rename some value. So, okay, for nonlinear model, we have to select this data, but make some operations for them. Which operations we have to do? For this data, when we want to create nonlinear model, we have to initiate a process named linearization. What is mean linearization? Linearization is a process when we want to achieve nonlinear model and we create new columns for our data and add linearization for this data. How we can do it? We add a formula, natural logarithm, and after that we achieved some new data for each of columns, for labor resources, for capital, for Y, and we will achieve information about linearization data. After that, we add this linearization data to the simple analysis, data analysis, and create simple regression for this data. But the main difference between nonlinear and linear model include that we will create regression not with star data, but with linearization data. Let's find this information here, and it's very simple process when we achieve new model. So for this, we add new three columns. Natural logarithm for labor resources, natural logarithm for capital, and natural logarithm for our Y. New three columns, and we calculate these values only in Excel because manual calculation it's very hard for you, for me, but we have Excel, so we can create these calculations. So first of all, about labor resources, uh, natural logarithm, ln, open brackets, and select data. Find first value and sorry for dog and add calculations to another cells. Okay, I create calculation and I know linearization value for labor resources. A similar calculation will be for capital and Y and our volume of production. Natural logarithm for capital. We achieved first value and after that recalculate all values here. Okay. And final calculation, we will find natural logarithm for Y and recalculate all this column. Okay, we achieved new data. We don't create any economic knowledge about this data. It's only calculations without any economic details, knowledge, etc. Only calculations. And after that, we can create a new type of model, non-linear model, and we will use this data for this model. How we can describe this model? We can describe this model via this formula. So we have we have y equate a0 multiply L squared a1 multiply capital squared a2. So you can see production function type of non-linear model, and we have to achieve this model, and in the future we will find only parameters a0, a1, and a2. Because here we know these coefficients a0, a1, and a2, and these coefficients, of course, we can see here into the column with coefficients. But our current task, our current goal to find the coefficients for this nonlinear model. So let's do it, and we prepare our linearization data. So after that, we go to the data analysis, regression, clear all cells. About our current start Y, it's our linearization Y, or maybe ln Y. About our X data, it's our ln L plus ln K. Our output interval, we have to know and select it, maybe here. That's all, press OK. And now we achieve information about non-linear regression. It's a very, I think it's very simple. It's a very, it's a like this regression, but you remember that we created this regression only for linearization data. So let's check this model via adequacy, via statistical significance. We can see our current correlation coefficient, determination coefficient, and of course, future criteria. Now we don't speak about test statistics because it can maybe a very hard parameter for you, but we can achieve this value and this value very quick. So let's compare our linear model and non-linear model. So for this, we see into our adequacy coefficients and compare them. So first of all, we have correlation coefficient. In linear model, this coefficient 0.83. In this model, this coefficient 0.84. So in this model, this value, we have value which are bigger. So here we have beta value, for example, beta value. So we achieve information that our model beta in the correlation coefficient case. For determination coefficient, here we have information about 0.69, here 0.71. Here we can see beta value, so we achieve information that our model beta with determination coefficient logic, maybe. About Fisher criteria, of course, we can compare this value, and you can see here we achieved better value because this value more than our previous value. So we can create conclusions that this model uh, creates better description for our data because here we have better correlation coefficient, better determination coefficient, and better um, Fisher criteria. So we know information. Now we achieved information that this type of model describe our start data better than linear model. So how after that we achieved this conclusion, and after that how we can find our current model correlation, model coefficients in this case. So for this, we go to the column with coefficients and copy these coefficients. Control C and Control V. I achieved this coefficient here and copy here. So let's create a name of each of these coefficients. First value, it's A, big A0. Next values, it's A1 and A2. So this calculation uh, found for us coefficients A1 and A2, and we can show this coefficient in our screen. But this model didn't find correct information about our A0, about A little zero, because it's not A0, it's A big zero. How we can find A little zero? We have to add formula. And in this formula, we select value exponent value, and go to this first value. I achieved coefficient A0 and copy coefficients A1 and A2. So now we show final values which describe our current model. So we can copy this model and substitute our A0 1.38, our A1 0.47, and our A2 0.61. So I only substitute our current A0, A1, A2 and add these coefficients in our model. So now we achieved the final view of our model, for our model, sorry. So that's all. We create linear model in the start of our class. After that, we create non-linear model, and we selected linear data and process of linearization. After that, we compare our linear model with non-linear model. We will achieve information. We achieved information that non-linear model better than our start model. And after that, we go to the coefficients, copy these values, and find our current coefficient for this model. And of course, write this information here about our model. So that's all. That's a final step of our practice 5.2.